Welcome to a video on solving systems of equations by graphing. A system of equations is a set of two or more equations that can be solved simultaneously. A solution to a system of equations in two variables is an ordered pair of numbers that makes both equations true. The numbers in the ordered pair correspond to the variables in alphabetical order. So for example, this is a system of equations. We have two equations with two unknowns. We want to find both the x and the y that make both equations true at the same time. For this system, x equals 1 and y equals 3 is the solution, often written as an ordered pair where the x coordinate is first and the y coordinate is second. Again, the reason this is the solution because if we substitute x equals 1 and y equals 3 into the first equation, we would have 1 plus 3, which is equal to 4, so it satisfies the first equation. And if we substitute x equals 1 and y equals 3 into the second equation, we also get a true statement. Therefore, this is a solution to the system. So if we are posed with the question, is 2, 5 a solution to the following system of equations, we have to make sure when x equals 2 and y equals 5 that it satisfies both equations, not just one. So if we take a look at the first equation, we'll replace y with 5 and x with 2 and see if it's true. We would have 5 equals 6 minus 1, or 5 equals 5, which is true. Now we must do the same to the second equation. So we'd have 2 times x, which is 2, plus our y value, which is 5, is equal to 4. So 4 plus 5 is equal to 4. Well, that's not true. Therefore, 2, 5 is not a solution to this system. Now, this video focuses on solving a system of equations by graphing. There are two other methods we'll look at in future videos called the substitution method and the elimination or addition method. But again, today we'll only be focusing on the graphing method. So what we're going to do is graph each equation on the same coordinate plane and then analyze the results. All of our equations will be linear, so three things can happen when you graph two linear equations on the same coordinate plane. The first possibility is you have one point of intersection, and this point of intersection here would be the solution. So if this was our system, the solution would be x equals 1 and y equals 3. If the graph intersects at one point, the system is considered consistent and also independent. Another possibility is we could have two lines that are parallel to each other. And on this case, the lines don't share any points, therefore there is no solution, and the system is called inconsistent and independent. But the main idea here is there's no solution. The third case is if we graph both lines and they happen to be the exact same line, then we have an infinite number of points in common between the two lines. Therefore, we have an infinite number of solutions to the system. And this type of system is considered consistent and dependent. So in general, if the system has at least one solution, we call it a consistent system. And if the two equations are different, we have an independent system. And if the two equations are the same, we have a dependent system. I don't focus too much on this vocabulary, but your instructor may. Okay, so let's give it a try. We want to solve this system by graphing. So what we're going to do is graph the first line, graph the second line, and analyze the results. So in order to graph this first line, it's in slope-intercept form. We have a y-intercept of positive 1. We have a slope of 3, or 3 over 1. So from the y-intercept, we'll go up 3 and right 1. So our line passes through these points. Next, on this equation, it's not in slope-intercept form, so we can make a t-table, we could find the intercepts, but I'm going to go ahead and solve this for y, so I'll subtract x on both sides, then divide by -2. So we have y is equal to 1/2 x minus 3/2. So our y-intercept is -3/2, or -1.5. Our slope is 1/2, so from here we'll go up 1 and right 2. And I'm going to go ahead and find a few more points. So our second line passes through these points. We can see that there is a point of intersection, therefore we do have one solution. The coordinates of that point represent our solution of -1, -2. So x is -1 and y is -2. Now you can see right away one of the disadvantages of graphing to find a solution is you have to be extremely accurate, and sometimes that's very difficult, especially if the x and the y coordinates are not integers. Here's another look at it using a graphing program. We'll take a look at how you can do this on your graphing calculator on the next problem. So again, we'll graph these two lines and then analyze the results. So for the first line, if we add x to both sides, we'd have y equals x plus 5. So we have a y-intercept of +5 and a slope of +1, or 1 over 1. Since I can't go up 1 and right 1, I'll go down 1 and back 1. The result would be the same. And so our line passes through these points. On this second line, I'll first start by subtracting 2x on both sides. Divide by -2 to obtain y equals x minus 5. So here we have a y-intercept of -5 and a slope of +1. So again, we'll go up 1, right 1 several times to get additional points. So our second line would look like this. And what we see here is these two lines are parallel, and that does make sense because our slopes are both equal to 1 and our y-intercepts are different. Therefore, this system has no solution, which we could also classify as inconsistent and independent. Now let's take a look at our graphing calculators just to verify this. What you can do is type the first equation in y1, which is x plus 5. Type in the second equation into y2, x minus 5. We'll hit zoom 6 to get the standard window. And again, this verifies our work. Now, if there is a point of intersection, the way you can find it is if you hit second trace and then option 5 for intersection, and then if you hit enter 3 times. Now we got an error because there was no point of intersection, but if there was, it would tell us the coordinates of the point of intersection. So for example, if I went back to the first problem that we did, and just to double check this, if I typed the first equation in y1, the second equation in slope-intercept form into y2, we do have to wrap up our slope in a set of parentheses and hit graph. Matches our graph perfectly, and just to verify, if we hit second trace, which is the calculation menu, option 5, and then hit enter 3 times, this does verify our work. And just in case I didn't say before, we could also classify this as a consistent and independent system. So our last example, we have these two equations. Let's go ahead and graph the first one. It's already in slope-intercept form. So we have a y-intercept of +3, and we have a slope of -1, which would be -1 over +1. So we'll go down 1 and right 1 several times. So our blue line would look something like this. For our second line, we'll use red, and we will solve this for y. So we'll subtract 2x on both sides, divide by -2, and we'll obtain y equals x minus 5. So we have a y-intercept of -5, slope of +1, so we'll go up 1, right 1 several times. Our second line looks like this, and it looks like we do have one solution, and that solution occurs when x is equal to 4 and y is equal to -1. So again, we have a consistent and independent system. Now, we didn't do one where we had an infinite number of solutions, but again, that would occur if you graphed both lines and it happened to be the same line. I hope it helps explain how to solve a system by graphing. Next, we'll look at how to solve a system using substitution and also by elimination.